To everyone, I am Professor Raja S. Worked as Assistant Professor EC Department at SNS College of Technology, an autonomous institution, Coimbatore. In this YouTube video, we are going to see about 19 ECB 301 Analog and Digital Communication subject under the topic of Modulation Techniques. So based on the previous video, you know about what is meant by modulation. Modulation is the process of adding message with the carrier for longest distance communication. So in this YouTube video, we are going to discuss the digital modulation techniques. So I welcome you for this YouTube video. So in this YouTube video, we are going to see what is the digital introduction to digital modulation, 11 modulation schemes, that is various modulation schemes I am going to discuss, geometrical representation of all digital modulation schemes, coherent and non-coherent deduction, some basics, then modulation spectra, how all the modulation output are visualizing. So why we go for digital to analog conversion? So digital to analog conversion is the process of changing one of the characteristics of an analog signal based on the information in digital signal. So any one parameter of analog signal is converted into digital signal. So in this YouTube video, we are going to discuss the aspects of digital to analog conversion, amplitude shift keying, frequency shift keying, phase shift keying, and quadrature amplitude modulation. So this diagram will show how an analog signal is converted into a digital and how a digital signal is converted into analog version. So if you see the left hand side of this figure, digital data is represented in the form of zeros and ones. Once it is given to the sender, the modulation will modulate the digital data with this analog signal. So if you see the intermediate part, the link is available. So in this link, the signals are transmitted in the form of carrier signal. Again it is sent back to the demodulator, where the demodulator again they want to see the original signal which is in the form of digital. So if you see this figure, digital to analog conversion is the process of changing one of the characteristics of an analog signal based on the information in digital data. So here data is in digital, sender send this digital with the carrier signal. So that is why in link it is represented in carrier. Again the data has to be retrieved in the receiver. So the carrier which is transmitted at the modulator side also removed in the receiver side. Again the data is in digital side. Next, why we need digital modulation? Digital modulation is required if digital data has to be transmitted over a medium that only allows analog transmission. Here modem is in wired networks and wireless must be used in analog sine waves. So now we see the types of digital to analog conversion modulation schemes. First one is the amplitude shift keying. So based on the amplitude, how a signal is changing. Second one is the frequency shift keying. Based on the frequency of carrier signal, how the data is changing. Phase shift keying, based on the pace of the carrier, how the signal is changing. And the combination of ASK and PSK is called quadrature amplitude modulation. So in general, digital modulation schemes are under three types. One is amplitude shift keying, second one is the frequency shift keying, third one is the phase shift keying. The combined version of ASK and PSK are called quadrature amplitude modulation. So this figure shows how the modulation and demodulation is carried out. So this figure shows the difference between all the digital modulation techniques. So if you see phase shift keying, the digital data modulates pace of the carrier. If you see the second figure, frequency shift keying, in this technique the digital data modulation will change frequency of the carrier. The last method is the amplitude shift keying. In this technique, the digital data modulates amplitude of the carrier. So if you see the first figure, whenever 1 comes, it starts with the above part. If 0 comes, it starts with the down part. If you see the frequency shift keying signal, whenever the 1 comes, the frequency are under high frequency. Whenever the 0 comes, the frequency are under low frequency. If you see the amplitude shift keying, whenever 1 comes, the signal are present. Whenever 0 comes, the signal are not present. So 1 means signal will present, 0 means signal will off. This is the criteria of ASK. FSK means whenever 1 comes it is under low frequency, whenever 0 comes it is under high frequency. When PSK, whenever 1 comes it starts at the top side, whenever 0 comes it starts at the down side. Then next we see the basics of modulation. So modulation is the process of translation the baseband message signal to bandpass signal at frequency that are very high compared to the baseband frequency. Demodulation is the process of extracting the baseband message back to the modulated carrier. An information bearing signal is non-deterministic, it is changes in unpredictable manner. Next, why we need carrier. Effective radiation of EM waves requires antenna dimensions compatible with the wavelength. So whenever we are increasing the carrier, we are also increasing the distance. So that is why in modulation techniques compulsory we are adding carrier with the message signal. So these carrier signals are mainly useful for very longest distance communication. Now we will see individually what is meant by ASK. If you see this figure, the baseband data is represented in 1001. So simultaneously if you see a ASK modulated signal, it is converted whenever 1 comes the signal are available, whenever 0 comes the signals are not available. So this is the brief explanation about ASK. Then we will see the advantages and disadvantages and applications of ASK. ASK transmitter and receiver are simple to design. ASK needs less bandwidth than FSK. The disadvantage is ASK transmission cannot easily corrupted by noise. The main application of ASK are it is used in earlier telephonic modem communication, and ASK is used to transmit digital data over optical fiber. Next, frequency shift keying. As I said previously, whenever the 1 comes the frequency are under high frequency, whenever 0 comes the frequency are under low frequency. So if you see this figure, 1 means very high frequency, that is F1 means very high frequency, F0 means low frequency, and in general it is represented in A cos omega c minus del omega t, and F1 is A cos omega c plus del omega t. So frequency shift keying, the frequency of the carrier signal is varied to represent binary 1 and 0. Both peak amplitude and phase remain constant while the frequency will change. So if you see this figure, 1 means the high signal are come, 0 means the low signal are come. The final, we have the comparison of ASK and FSK. Amplitude shift keying are very simple compared to frequency shift keying, and it also a low bandwidth requirements, and it is very susceptible to interference. Whereas in FSK, it needs a larger bandwidth and it have a less noise compared to ASK. The final type is the PSK, phase shift keying. So in PSK, if you see the figure, whenever 1 comes, it starts with the upper part. Whenever 0 comes, it starts with the downer part. So this is the representation of PSK. In phase shift keying, the phase of the carrier is varied to represent 2 or more different signal elements, that is both peak amplitude and frequency are remaining the constant value. So in binary PSK, we have only 2 signal element. We know that 1 means it is available, 0 means it is 180 degree out of phase shift. So thank you for watching my video. In the next video, we will discuss about all individual digital modulation scheme like ASK, FSK, PSK in individual manner. So once again, thank you for watching my video.